let's take a look at two theorems today, which will tell us something about distance, about how far apart 2 points are, and then midpoint. What would be the middle of sort of the line between 2 points? So the first theorem, the distance theorem. The distance between 2 points is given by taking the square root of x2 minus x1 and square it, and then you're going to add y2 minus y1, and you're going to square that. Okay? This looks very complicated, but it's really just the Pythagorean theorem. Let's look at an example to show this. So let's take the 2 points, 4, 2, which is right here on the graph, and -3, -1, which is right here on a graph. I want to know, given these 2 points, how far apart are they? So if I'm to draw a line between the two, what would be that distance? Okay. In class today, we talked about completing this and saying, well, if I was to do this point, how far apart would they be? 6. And then up to this point, how far apart would they be? This would be 3. Well, isn't this a right triangle? So I could use the Pythagorean theorem to get 3 squared plus 6 squared would equal the third side squared. Let's take a look at this. One way of getting 6 is to say, okay, well, at this point of -3 and -1, and at this point here, this would be at 4, comma, -1. So what I can do to get, should be 7. Okay, made a mistake there. Sometimes happens in counting the lines, doing it too quickly. In getting 7, how do I know it's 7? Well, if I do 4 minus the -3, these become plus, I get 7. Or I can do -3 minus 4, which would give me -7. Okay, either way, when I then square it, I'm going to end up with 49. Okay. Why is this important? Well, if we label each of the points, let's say 4 is going to be my x2, my 2 is going to be my y2, my -3 is going to be my x1, my -1 is going to be y1. Okay, these are arbitrarily chosen, meaning that I could call this x1, I could call that x2, it doesn't really matter. But when I begin looking at taking my square root, being my distance equaling the square root of my x values, the 4 minus the -3, and then squaring it. What I want you to begin to notice is that it's really the same exact thing I did to get this distance. Okay, subtracting these two y values to get this distance of 7. Why is the distance formula helpful? Because I don't always want to draw things out, especially not when like the length of something is 100 feet. Okay. Then I look at the second side. Okay, kind of using the same point of 4 comma -1. Okay, this point is at 4 comma 2. So I get the 3 by doing either 2 minus a -1, focusing on the change in y. I start off at +2, I end up at -1, and I get 3. I could also do -1 minus a -2, minus a +2, and get -3, which once again, if I square both of these, I end up with 9. And that's what ends up happening then. So to that, I'm going to add sticking with the numbers. Okay, if I do y2, it's going to be 2 minus my y1 of -1, and I'm going to square that. So basically, I'm going to end up with the square root of 7 squared plus 3 squared. So I'm going to get the square root of 49 plus 9. In other words, the square root of 58. Okay, to get to my answer. So, why is this important? Well, let's take a look. If I had used the Pythagorean theorem, I would get that my d, this third side, would equal, it would be d squared equals 7 squared plus 3 squared. And in other words, if I were to take the square root, d would equal the square root of 7 squared plus 3 squared. Where does this look important? Look what I have up here. Isn't that the same exact thing? So really what the distance formula is using the Pythagorean theorem in a way that's a little bit more compact. Even though it might not look that way, okay, it's basically taking the two x values, subtracting one x value from the other, then squaring that. And then to that, doing the same thing with the y's, subtract the two y values, then squaring it. Adding those two together, then taking the square root. So this is a situation where the formula looks a lot more complicated than what it really is. Point. When I look at the midpoint theorem, it's actually a little bit easier. The midpoint between 2 points is given by averaging the two x values, in other words, adding them together, dividing by 2, and then adding the y values and dividing by 2. Why does this work? Let's look at an example. So if I give you 2 points, I'm going to use 4, 2 again, okay? And then just to make things a little bit easier, I'm looking at -2, -6, okay? I want to say, what is going to be the midpoint of that? So basically what we begin doing is saying, okay, well, tell you what, let's look at the x values. Okay, those are the lines on which they occur. I want to find what would be halfway between these purple lines. So if I'm at -6, it's going to be at -2, okay? There's going to be 4 blocks here, 4 blocks here. So therefore, I'm thinking that my y value will be -2. Okay, based off of where it should be height-wise. Okay? What I then want to do is say, okay, well, if I'm going to look at, gotta find another color. Let's use like an orange color. Okay. Let's look at my x value. So I've got one x value here, or one x value here. What would be halfway between those lines? Well, if I go 3 from either direction, I get x is equal to 1. So I think my value is going to be 1 when x is equal to 1. Okay, why is this important? Well, if I use the theorem, okay, the midpoint formula, or the formula, distance theorem, midpoint, or distance formula, midpoint formula. If I use the midpoint formula, I'm going to do 4 plus a -2, and then I'm going to divide by 2. So 4 plus a -2 is going to be +2 divided by 2, which is going to give me that value of 1. If I look at my y values then, I'm going to do 2 plus a -6, and then divide by 2. So 2 plus a -6 is -4, divided by 2. -4 divided by 2 is going to be -2. So therefore, this is giving me my midpoint, which matches up with exactly where I thought it would be graphically. Why is it the formula important? Well, once again, you're not always going to want to have to draw everything out. And it's not always going to be easy to count. It might be a half or a third or something like that, where you're not going to be able to do it on a graph. So that's why it's important to have the midpoint formula. Like I said, you're basically just adding the two x values, dividing by 2 to get the x value, adding the two y values, dividing by 2 to get the y values. So midpoint formula is a little bit easier. The distance formula or distance theorem is not that hard, but it does look very scary until you begin to know and to realize that it's really just the Pythagorean theorem.